Okay, next up is problem number 5. Problem number 5 has got a lot more pieces to it. First thing I'm going to do is just try to draw the picture. So if I try to do that and get the actual look of our baby carriage here, what we should see is hopefully we can get kind of a feel for what the baby carriage kind of looks like. So here is my baby carriage. So basically a box, put the little top on, and then we'll have our baby inside. And then it has a handle on it that's pointed up like this. So the idea is this 75 kilogram baby carriage, so the 75 kilograms in there, there's our mass, is pushed at constant speed along a level sidewalk by exerting a force of 20.5 along the handle, which slanted at 50 degrees above the horizontal. So what that tells me is that the force is actually going to be along this handle. So I'm going to draw it in blue to indicate that it's actually acting in this direction of 20.5 newtons. And it's acting at a 50-degree angle. So when we get that situation and we know it's moving, we also have friction acting on this thing. Friction is going to be acting to oppose the motion of this quantity. We also have other things. We have the weight of this object acting downward. The weight would be equal to its mass times gravity. So that's going to be the 75 times 9.8, which is going to be 735 newtons. We also have a normal force acting on this object. Draw it in purple. It's going to be an upward force acting on this thing. Now the normal force could equal the weight, but it's also going to have this little m times ay. Now I don't actually have an acceleration in this direction, but this part of it is going to come from the fact that they are applying their force at an angle. So one of the things I have to do, which is totally different in this problem, is I have to take this 20.5 newtons and figure out how much am I pushing forward on this thing. So how much of a horizontal force do I have? And then also how much of a vertical force do I have? How much am I pushing down on this object? And if I can get both of those, then I should be able to figure this out. Well, those two would just form a triangle. So if I draw it down here, Fy and Fx would form my 20.5 newtons, which is my 50 degrees. So using some of our trig functions, we should be able to figure out Fy and Fx. This actually goes back to chapter 1 stuff. Fx would just equal this 20.5 times the cosine of the 50 degrees. And my Fy here would be 20.5 times the sine of 50 degrees. Putting those together, we should be able to actually figure out what Fy and Fx are. Now I can go into the basics of this particular problem. If this thing is moving along at constant speed, this tells me that the Fx should just equal the friction force. And the reason why is because I have no net force in that direction. Also, my normal force is going to equal the weight, but since I have a downward force acting on this thing, this is acting downward, it's going to increase that. So I'm going to add whatever Fy I'm applying to actually figure out my normal force. Once I have those, I know a way of going about finding Fx. This also equals mu times my normal force. This allows me to find out what the normal force is, and I should be able to plug it into here. I've already figured out what Fx is. The only thing missing is my coefficient, and that's what I'm after in this particular problem.